Hey guys, welcome back to another episode of Simuleo. So, I think the audio lag issue should be a little bit better today. It's still not perfect, but it should be a little bit better. I added some audio latency to one of my audio channels, and that kind of fixed the issue. It tended to be that the recording issue, it was only an issue when I was actually like recording something, you know, so it doesn't look like an issue when I'm just looking at my output, but for some reason there is a latency between the audio channel, the jack audio channel in particular, and the audio channel that's used for like, well, everything else. So like there was a video, I guess, timestamp, and then there's an audio timestamp. I really don't know how to describe this, but I think it's better. It's probably not perfect. There's still probably something off, but I can't really tell what it is from looking at it. Okay, so I've got a couple things I want to talk about before moving into the programming. So let's go ahead and open up Zernal and let's get started. So Zernal. Okay, let me just draw on it, erase it, draw on it again. You know, typical thing, because there's that bug and I don't know what the bug is. Audio is still about 200 microseconds early. Is it early? Because before it was late. So let me think, if it's 200 microseconds early, yeah, I can check it. I can fix it really quick. So I found out how to do that, right? Like we go here, then we go to advanced audio properties. So if I drop this to 800, you think it's going to be better? Let me try that, and then you'll tell me I'm wrong. So let's do 800. And in principle, I can change that while I'm also streaming. Let's see if that does anything. I actually have no idea. Okay, so let's go ahead and talk about a few things real quick. So you guys know 3 blue, 1 brown, right? So let's do 3 blue, 1 brown. Okay. That's all caps because I felt like writing in all caps. Here's the thing. As of yesterday, I actually had a talk with this guy about stuff that we could potentially do. And I'm not going to say exactly what we're going to do, but it is something that we kind of decided we kind of want to work together. We just didn't know where. Obviously, I mean, he's a much bigger channel than mine is. So anyway, I talked to him about a couple of different things. And one of the things I did talk to him about was the math animation library he has called Manim. Okay? Now, here's the thing. Let me just fully go through this topic for you guys real quick, because it's one of those things that after this last visualization, I really realized I do not like using OpenGL for this type of thing anymore. And I'll show you exactly why. Now, you guys could probably argue that OpenGL is better for a lot of reasons, and it is, and I'll go through those arguments. But let's just show this last visualization did. So let's do cd project scivl ls, and let's do /scivl s stable. Okay, here was the idea. We have all the guys, they all line up. We have all the girls, they all line up. After that, we have the list of all the guys and the order in which they like the girls, and list of all the girls in the order in which they like the guys, right? The guys go and they propose, and then after they propose, then they just move around until eventually they all find a stable placement. And that should be about right. Yeah, I believe that. So in this case, it doesn't mean that all of the guys have, hey Gwenerth, it doesn't mean that like they all have their favorite relationship, but it means that they have a relationship that is okay, you know, stable marriage, not necessarily their favorite marriage, right? Now, what I was going to say was that, let me check something real quick. This animation took for absolutely ever. It was really hard to do, and it wasn't just because, you know, the algorithm was kind of complicated, which it was unexpectedly complicated, but it was also because of a number of other things, you know, some things that I'm not particularly happy with this visualization library. The way in which I move all of these characters is kind of weird, you know, the way I've set everything up is kind of weird. And this is due to my own inadequacy in programming OpenGL. There's a whole bunch of other things here too that I don't like. The fact that it looks like the internal circles here are kind of squarey is because of the way that I have to draw lines, because I couldn't figure out how to draw lines in any other way with OpenGL. You know, I ran into a whole bunch of weird issues. Create separate frames for the animation, export them to PDF, print them on paper, make a flipbook and record it as a movie with your cell phone. Actually, Buttercake, here's the thing. I was comparing this animation here that I just did, which was kind of okay in quality, you know, to some of the animations we used to do. And let me just do one of those animations really quick. I'm going to cd into projects. Then I want to do, I guess, Simuleos, do a quick ls here, cd into, I think I called it invisible lens. Yeah, ls here. Come on. Then I guess, which one is it? It's going to be a.out, maybe. I don't actually know what this is. Where's our make file? Oh, it's been a while. Do we have anything in frames? No, we don't. So let's just look at vi makefile, I guess, and see what's in here. But oh, makefile 2. Jeez, I did not know what I was doing. Let's go back a bit. Let's check something else, something that I know probably works. And how about we just go into oh, I don't know. Well, let's just go into Huffman or something, ls, and let's go into, do I have anything in frames right now? I do. So let's go into Mirage frames, and then image 00 whatever .png. Okay, so here's one of the old animations we did. It is currently black because there's nothing in this image. But if we scroll down, we get all of the characters and stuff being drawn. We have this being drawn, and all of this being done. Okay. This animation would be incredibly hard for me to do in OpenGL, but it would be possible. The issue I have with doing it in OpenGL is that the way in which I'm drawing everything is very convoluted and weird. That's one problem. The other problem I have is that it's done in real time. And this is actually a bigger problem than I thought it would be. So the nice thing about having this not done in real time is that I can literally just come in and I can scroll through all the images, and if there's a bug or something that's going wrong, I can very slowly sift through what's going wrong, right? So what ended up happening with the with this previous animation that we did, there were a whole bunch of bugs that kept popping up because I coded the algorithm incorrectly, but I couldn't tell what those problems were. Because as I was going through and I was trying to figure out where the animation was breaking down and what was happening, trying to kind of debug everything as it was going along, it was very hard because I just had to keep running the simulation and hoping for the random off chance that the algorithm would mess up and I could see what the error was, you know? And that was kind of weird and difficult, and there's a whole bunch of really weird things. I don't think a debugger would have helped here. Like, you've said this before, but I don't think a debugger could have helped. I mean, I could have set the random seed appropriately, right? No, wait, I'm trying to figure out how a debugger could have helped here. Because, okay, I could have figured out what the seed was that was generating... No, but that's not the... I don't think that would have helped either in this case. Like, my problem was that with one random seed, it didn't work, right? So I needed to figure out which seed it didn't work with, and then kind of analyze the output there. I'm trying to think. And then what I needed to do was just pause the simulation. You know, just be like, okay, I want to stop these guys moving here, so I can see what this time step looks like and this time step looks like. So yeah, I guess we could have used a debugger for that, but I would have had to output the... that would have been a pain. Yeah, I guess I could figure out how to do that, but I don't know. There's also another issue. So there's a number of other issues with the OpenGL stuff. The biggest issue is that I can't output it frame by frame. And I know that doesn't sound like an issue, but it's actually a huge issue for recording, because what ends up happening is if I want to get the recording of this guy over here, I don't know how to do it. I have to do it either grab the frame buffers and output it to a set of images, which is a pain in the butt and I haven't been able to implement yet, or I use OBS in order to grab the output, which is what I have been doing, and I really don't like that solution because it makes it so we then have another layer of I guess recording on top of this visualization. Yeah, RR I guess could have helped too, but it depends on how I'm doing the simulation here. Yeah. Yeah. Okay, so then I don't like that recording thing. Basically what I'm saying is that I am not the biggest fan of using OpenGL in the future for this kind of stuff. I mean, it's fine. Don't get me wrong. I like OpenGL. It does things in real time. But the only reason we switched to OpenGL was so that we could do the Barnes-Hut algorithm in 3D. And we are so far away from doing anything in 3D right now that I really feel it's probably best to ditch OpenGL and go back to Cairo, or switch to the Manum library that 3blue1brown uses. Now, let me just go ahead and pop over here and show you the Manum library. So Manum, I'm sure I googled it. Okay, so the Manum library is quite good. It obviously does a whole bunch of things right. I mean, his mathematical visualizations are top-notch, best on YouTube, that type of thing. But as I was talking to him about it, it kind of, I got some, how do I put this? I got the vibe that he didn't necessarily want to turn this into a package that would work for, like, would be a general purpose library for usage of creating mathematics animations, if that makes sense. Like, the thing about this is it's a good repository for 3blue1brown's videos, but, you know, there's a couple things here, like there isn't a license, and if you go to active projects, these are the active projects of 3blue1brown, and if you go to old projects, these are all the old projects of 3blue1brown. I mean, it's great that he has this. Here, I'll link it to you. In fact, I think this is amazing that he has this available. But I just feel like there's some stuff here that we need to, or we would have to kind of sift through in order to make it useful for our purposes. And even then we'd have to implement a whole bunch of new animations, and basically we'd have to redo all the stuff that we've done already with another animation scheme, if that makes sense. Like, just because honestly, we have a different aesthetic anyway, right? And the visualizations that we do are different. So in the end, it kind of doesn't make sense exactly to pull off of what he has. On the other hand, it doesn't make sense not to, because in some sense, if I'm making my own animation library or something like that to do very similar animations, why would I do that when I could collaborate on one that's already out there? There's a few other things about how this is done. If I just do Manum, if I just Google Manum, I'm sure I'll find what I'm looking for. Maybe Manum examples. So the way that Manum works is in this way. Okay, so we have basically the idea. Let me see if I can increase the size here for you guys. Okay. Oh, that was maybe too much. I'm sorry. Let me try dropping down. So, like, you create a class draw circle scene. You construct here. You say circle, and then you play show creation of circle, right? So it's kind of done in this way where you create a class which is basically a scene of some sort, and then you go scene by scene. Which is an interesting way to do it. So I guess no matter what we do, we're going to have to kind of think about how to do the visualization in the future. Okay, so basically all this to say, I'm not really happy with the OpenGL visualizer. I'm looking for a new visualizer, and I'm thinking about just going back to Cairo for a bit. So for this visualization here, I want to go back to using the Cairo visualization, just because that one seemed to be cleaner and crisper and just better in like every way. So I kind of want to work with that one again. And then after that, we'll see how that one goes. And then I can try to learn the Manum library. I'm going to have to take a week off, unfortunately, because I'm traveling with friends. And when that happens, I'm going to have to take the time off anyway, so I might as well try to learn the Manum library then. But right now it's probably a little bit too difficult to learn on the side. So, but I was wondering what you guys thought, if you thought that, you know, what we should do for the visualization library from now on. I'm quite keen just to go back to Cairo and work on that. But I'm also keen to try the Manum library and see how that goes. Again, the other thing too is he's got all of these really good animations already built in. So like, let me see if I can do this right. I use the library really quickly just to do something simple. Let me go ahead and open up a new terminal over here. And drop it down so it's the same size. Okay, CD into, I guess, what did I call it? Let me do quick ls. I want to do ls media, maybe? No, where did I put this? He had a very particular place to put this. Build checkpoint, desk point. 1 second, let me just full screen here. Do a quick ls. Build checkpoint, grayscale, LMS media. Is it media? Yeah, it is media. Okay. Then we go to CD animations, ls and CD example. So like, here's this example real quick. So if we do MPV, square to circle, like this is a really cool animation for like the example, right? Like it's just create a square, move it to a circle. GitHub 3 Blue and Brand animation engine 4. Oh, the old animations were nice. If they're much easier to create, then go for it. Yeah, they are easier to create. So, oh, JSPP is coming in. That's fine. Yeah, I think I'm going to go back to the older ones. I mean, we tried OpenGL. I'm happy with how far we got with OpenGL. It's just not, it's not great for the stuff we want to do. Because we want super high resolution stuff. And the thing with OpenGL is we can make it high resolution, but then I have to record it, screen cap it somehow. And so I'm kind of limited to the resolution of the screen that I'm working on, and there's a whole bunch of other weird issues with it that I'm not particularly happy with. Hey JSPP, thanks for coming in. And everyone else, thanks for coming in. So that's kind of what I wanted to talk about very quickly, just to see what you guys thought. The other thing I wanted to say was, so that last video I put out wasn't particularly popular, and I'm not exactly sure why. I mean, it could be the visualization wasn't great, but I thought it was okay. So I didn't really know what was up with that one, but it could also be because I released it on a weekday instead of a weekend. So I guess maybe from now on I'll just put videos out on Sunday, and just, if I can't get the video out on Sunday, I'll just try to make it for the next week. Because it tended to be that, I don't know, I wasn't really sure about that one. So I guess we'll figure that one out as it goes along. It was just kind of weird that it only got like 300 views in a day, you know, like I figured it'd get more, especially considering the channel has over 10,000 subscribers. You know, you'd expect at least 10% of people to come back and watch it, but that was not the case. So I need to figure that one out. Also working with a couple other people. I asked for collaborations with like a number of people. We'll see who responds and who doesn't. And kind of go from there. Okay, so what are we doing today? Today, we are going to get a very simple implementation of Euler methods working, in particular the forward Euler method. Now, I know what you're thinking. Man, you know, Laos is great. He probably, you know, totally looked this up beforehand because he wasn't arrogant enough to believe that he could relearn Euler methods in, you know, on stream or anything like that. Yeah, I totally didn't. I need to look up Euler methods because I didn't do that beforehand. I'm so sorry. I was so busy as of yesterday, you know, because yesterday morning I put the video out, and then all morning I was working on just the video stuff, and then all afternoon I was working on stuff, you know, for 3 Blue 1 Brown, and I just kind of ran out of time. I'm sorry about that. I kind of wish I could have more time, but I don't have more time, so that's how it is. So what I'm going to do next is look up Euler methods real quick. So I'm going to go to the algorithm archive. Now, this is probably the worst chapter in the algorithm archive right now. I need to revise it, which is kind of why I wanted to go through it to begin with. So we go to read, and we go to, let's see, what do we have here? Should be Euler methods. Okay, so again, worst chapter in the algorithm archive by far. Let's see if I can actually read and figure out what I was trying to say here. And then after that, we'll go and do it. I'm pretty sure it's pretty straightforward, though. So I start with a bit about Taylor series expansion. That seems fine. And for the kinematic equation, oh, okay. So for the kinematic equation, this is pretty much the same as the previous Relay integration. So JSPP Buttercake, not doing it fully with C#. I want to go quite object-oriented programming. I'm doing things that aren't object-oriented programming. Fair enough. So I think in terms of the pull requests that were sent in, I will go through those pull requests after going to the gym, so I'll do it over breakfast today. Sorry about that. I just hadn't had the time to do it. I literally just woke up like an hour ago, so I mean, I could have gotten up earlier. I was actually awake earlier. I just didn't get out of bed. I don't know what the deal was this morning. I just could not motivate myself to get up. So here's the thing about Euler methods, and this is the thing I do remember. We have forward Euler methods and backwards Euler methods. The backward Euler method and forward Euler methods basically differ by, basically, wait, that complexity that, wait, that's the complexity that actually does make sense. I'm not sure what you mean, Gustorn. Sorry about that. Oh, maybe you're talking about the C# implementation. So the forward Euler methods can be, it doesn't make sense as separate classes from anyway. Oh, I see what you're saying. Yeah, fine. Okay, so what I was going to say was, with Euler methods, there we go. We have forward Euler methods, which can be done rather straightforwardly, basically the same as Verlet integration. But backwards Euler methods, including the Crank-Nicolson method, need some sort of, they're implicit, so we have to do some sort of solving on top of the method itself. Now, in some sense, this is kind of meh, you know, in that we have to do the solving on top of it. In another sense, it's actually not so bad, because it means that we can ensure stability. It is implicitly stable, or something like that. So this means that we don't run into weird stability conditions. So what I want to do for the Euler method is, I guess do something quite straightforward for now, which is just going to be, again, solving for the kinematic equation. But the thing is, these can actually be used for any ordinary differential equation, so I do kind of want to show that somehow. I'm just not sure the best ODE to work with, so maybe we work with another ODE for this particular visualization. Because we did the dropping the ball for Verlet integration, and Verlet integration is, in particular, for, how do I put this? The Verlet integration is for moving objects. Euler methods can be used for other things, not just necessarily moving objects. So, let me just Google some good ODEs to work with. Fun ODE. Let's see what we have. Differential equation. That's probably not it. Fun ordinary differential equations. See what we got. Math is fun. Differential equations. Let's go. This isn't great. Okay. I think maybe the heat equation or something. I'm not sure. Okay, let's just do gravity for the day, and then we'll go from there. Let's pop this over there. 1 second. There. Great. And we're going to pop over here and do... it doesn't matter. So let's go ahead and CD back a bit. CD back a bit. CD into projects. Simuleos. CD into projects. And Simuleos. And let's just do something rather straightforward just to make sure we have something working. I'm going to do a quick ls. Make directory Euler. Euclid. CD Euler. What? There we go. Okay. So as always, we need a good makefile. Let's go ahead and CD into projects. Oh, I'm already there. Euler. Okay. Let's see. What was the last visualization we did? It was a long time ago. I think... I think we should do... What is tunneling, even? I don't even know what this is anymore. But I guess we'll go ahead and take one of the previous makefiles out and use that for a bit. Let me see what we have for visualization, too. CD visualization. What do we have? Fourth dimension Monte Carlo, Cairo, CD Cairo. Okay, so we have a makefile here for a visualization test. What happens if we do that? Let's just do /viz test. Does this even do anything? I'm not sure what this does. 1 second. Maybe this is a bad idea. Quick ls. I don't know what that did. Maybe ls in temp. Ah, there we go. We have a bunch of images. Are these the correct images? Let's do Mirage. Image. I don't know what I'm doing. Image 000 with 000.png. What is this? Apparently it's nothing. Nothing. Oh, there we go. That's stuff. Oh, that's wonderful. Okay, there we are. Back in the good old days. Oh, I also put 120 on one of these. Ha. Okay, let's see how this goes. I've got a feeling it's going to be really, really weird. Let's do a quick ls and let's go into vi viz test.cpp and let's see what we were actually doing here. I've got a feeling this is actually much harder to use than I thought it would be. So we have vector, the resolution is 400 by 300. We have some sort of FPS, which I set to 30. We have a background color, which is 0001. I can change that background color, obviously. We have layers, which is basically a vector of different frames. We initialize the layers as 3, the resolution, FPS, background color. So that means we have 3 layers. 1 second. What do we need 3 layers for? I don't think we need 3 layers. Oh, I know the deal. Ha! That's amazing. Wow, I didn't realize I was that stupid. Okay, no, that's great. This is great. Okay. Okay, let's keep going. So what else do we have? Instead of the Lingua group has a list to track the potential partners. Did the music stop? 1 second. No, it didn't stop. It was just lull real quick. Okay, pop back over here. What else do we have? Layers here, create frame, init frame. I think, oh, init layers is already created, so I think I can delete these guys. Let me see, what else do we have? Color, human color. So I guess this was just to test the animations to make sure they're working. Draw permutations. What is this? Vector array, draw permutation. Oh, okay. I don't have any subroutines for this guy, so let's go ahead and DEG. Great, right quit. Okay, I'm kind of happy with that. In a way, in kind of a weird way, so let's pop over here. And let's go ahead and do CD projects. Simuleos, visualization, Cairo, and let's do a quick ls. And I'm just going to keep that visualization test up on the side just to see how it goes. So we're going to do vi viz test.cpp. Pop over here, and now let's go back to the Euler methods. Oh, actually, I should probably look up the make file. The music just went quiet again. What? I mean, it's here. I'm listening to it. But I don't know. We'll see. Maybe it stays quiet for a bit. So what am I going to do? I'm going to cd into Euler. Okay, so what I want to do today, and I know this is going to be really, really dumb. I want to do a very basic, I want to drop the ball, make it hit the ground, nothing complicated. Just something super straightforward. So let's go ahead and do, I guess, vi Euler.cpp. And I guess what I also want to do is pop over here real quick, quit, and let's go into vi makefile, see what we have. I think what I'll need to do is grab this makefile and basically use this in the end, makefile for general visualization. Okay, so I'm going to very quickly start some stuff. Leo singing would be better though. Ha, 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 I'm not going to sing. So let's keep going from there. Let's do 78A dash because I like, you know, dashing something like this, paste. 1 second, Discord chat just went down. The Gathra sent a link in Discord. Euler differential equation. Yep, good. Let's go ahead and X here, A there, and add this here. I like this. I know Gusterman doesn't, but I do. So I'm doing it. And we're just going to do Euler.cpp. Great. Okay. Hey, Roxano. Should have typed the music is still playing quietly. Introduction to a new scene in the Simuleos movie. Wait, what? How is this a new scene in the simulation? Oh my gosh, I can't speak at all today. I'm so sorry. So what I'm going to do here is I'm going to say to implement a basic version of Euler methods for random things. So I guess the way I want the video to go is to start off by talking about Verlet integration and say, hey, this is something we did before where we dropped a ball, but what if we want to generalize it to other ODEs? So we do first Verlet integration versus the Euler methods. And then after that we do, we have the two. Then I show some instabilities of the Euler method. But I didn't say, but there's a power in the Euler method, because the power of the Euler method is that it can be used for general ODEs, which is great. And then after that, what do I say? I then will say, and there's a way to make it implicitly stable, and that is to use backwards Euler methods, but they're a pain to implement, and so we leave it at forward Euler methods. That's what we leave it at. And I think that's probably a good way to end. So I think that's what we'll do. If you have a book that's just dialogue, that would be background info for, wait, that's in there sometimes? Wait, I'm missing something. Introduction to a new scene in the Simulaios movie. That'd be cool. I don't mind which animation library he uses. If you have a book with just dialogue, that would be the background info that's in there sometimes. Okay, so let me think about how we have this done. Is it desync getting worse? I think, Buttercake, you were the one that told me it was 200 milliseconds off. Let me think. If there's... I can change it if you want. I'm not sure how you want me to change it. Is it slow or is it fast? That's what I need to know. So let's pop up here. What? Let's just do a quick... What on earth? Come on. There we go. Why is this so laggy? There we go. Let's do something. I think what I'm going to do is just very quickly get something working and then go from there. So for the makefile, I'm just going to go into VI makefile. That wasn't it. VI makefile. And let's just grab this makefile because, you know, I'm so good at this. I just... and instead of KairoViz, actually it is dependent on KairoViz.h. What I want to do is change this object to Euler.o, change the binary to Euler, and I guess it's dependent on include. Oh, I guess it's going to be visualization KairoViz.h, and I believe the vec.h is in the same location. Do a quick ls, yeah. Even though it probably shouldn't be. Okay. Clap your hands once in front of the camera so that we can see how bad the desync is. How about a snap? Is that okay? Video follows behind audio. Let me think. Yeah, I think that's true. So the video should be a little bit slower than the audio. I have to add latency to the audio. So what I want to do then is, I don't want to do this just yet. I just want to do the compilation. So let's go ahead and remove that. And then I don't want to convert it to an animation.gif. That's not what I want. We have CXX, CXX flags, Cairo flags. This should in principle work, I suppose. So I guess what I'm going to do is very quickly see what happens if I go into vi euler.cpp, pop down here, run int main, pop down here, and just do a quick hello world with the makefile. Okay, so let me just go to OBS real quick and let's change the settings and see what happens. Let me go here, advanced audio properties. I had this set at 1,000 stream, which seemed okay to me. Maybe that helps it, I'm not sure. Hello world, great, we are totally getting there. I'm so good at this, make that. Dang it. I know the problem. VI makefile. It's because these guys are all wrong. Oh. Try making it again. What do you mean you're missing a separator? Now I'm confused. It says it's at 5. 5. Ah, shoot. That's my fault. I should have just CP'd, but I didn't CP because I thought to myself, oh, what could possibly go wrong? I learned what could possibly go wrong. That's what could possibly go wrong. So d. Right, quit, make that. See out. Of course, wait, what do you mean? Oh, it's because I didn't. One of these days I'll learn how to code in C++, but that day is not today. Include, let's do it, IOStream. Make that, see what happens, make that. And no rules, make KairoViz.cpp, need by KairoViz.o. 1 second. Yeah, I make file, and there should be a KairoViz somewhere. Visualization KairoViz.h. Where is it? Cairo.viz.cpp. So this is going to be in, I guess, visualization Cairo. See how this one does it. One of these days. There we go. Let's do make that. That one seemed to work. So if we do /Euler, we should get hello world. Great. Okay, we're getting there. All right. Only channel on Twitch that spends 47 minutes writing hello world. Okay, so let's go into Euler.cpp. Oh my gosh. The old delay. Wait. Freezing moon. I don't even know how the audio is in sync with the screen capture, even though it's delayed by 1,000 milliseconds now. I don't get how the audio is in sync with the screen capture, even though it's delayed by 1,000 milliseconds. Yeah, I don't know. Twitch built-in stuff is fancy animated in chat. Wait, what? Let's check what you're talking about real quick. So if we go to Simuleos, delay. Clap your hands once in front of the camera so that we can see how bad the desync is. How about a snap? Is that okay? Video follows behind audio. Yeah, okay. So you're right. There was a bit of a problem there. I'm not sure what the problem was. Okay, so let's keep going. So what we're going to do is a very simple Euler method test. And again, the idea here is that we're just going to drop a ball from 5 meters and see how long it takes to hit the ground, because we know the answer to that. So I guess what I'm going to do then is, because we know what the Euler method is for this particular case, it literally boils down to the velocity of relay algorithm. I'm like 90% sure. I mean, so let's just go ahead and do that. Because we know what it kind of looks like. And for gravitational stuff, it's fine. There are boxes instead of links in the chat with little pictures. Oh, yeah, I see what you mean. Sorry about that. So also, when I was talking to Grant yesterday from 3 Blue 1 Brown, man, I'm just talking too much. I'm so sorry. But when I was talking to him yesterday, he mentioned that he kind of did the YouTube thing full time, like the math animation thing full time, at around 70 to 80,000 subscribers or something like that, which is much smaller of an audience, I thought, than what I thought he had at the time. But I also think there were a lot of people who really, really liked his stuff, so they ended up giving him a lot of money on Patreon or something like that. Let's see. The Gathros, we drop a ball and see how long it'll take. Wait, so we'll be here forever. That was what Gathros said on Discord. So let's go here and let's just do something quite straightforward. And what do I actually want to do? I guess what I want to do is return something like this. So we'll do double Euler, I guess, ball. I don't know. We'll figure this one out. What all I need to do is read in an initial height. So we're going to do double height. Then we do, what else do we need? I guess we can do initial velocity, but I don't think we really need that. Let's just do double height for now. And let's just solve this quite straightforwardly to make sure we have something working. Okay, so the question is, how long does it take to hit the ground? And I guess it is, while we haven't hit the ground yet, we just keep moving forward, right? So we have an initial height, and I guess we'll say, we also have a location. How did I do with the relay algorithm again? Let me just go and check what we have. If I go into relay integration, let's see, I want the C++ one, and void relay, position, acceleration, double DT. Yep, that seems okay. And then we say while position is greater than 0, time plus equals dt. I see what I did. Okay, so what I actually want is a position acceleration to dt. And that's how I want to do it. So let's do it. Did I return anything? I returned nothing on that one. Oh, I see why I returned nothing though. So we want double position, double acceleration, and double dt. Sure, that'll do it. And for the Euler methods here, what else do we need? We have position, acceleration, double dt. But I'm not returning anything because I'm returning time at the end. But I don't think I want to return time here. I want to return the new position. So in this case, we will be returning the new position of the ball after moving forward one time step. Oh, great. Move forward. One second. 1 dt. Perfect. Great. Totally didn't have to fudge that one a bit. Okay, so we have the current position, and I guess this should be rather straightforward, right? We just need to say return. We have the acceleration. We know the velocity, so I guess we're going to say double v is going to be equal to it's just going to be whatever v is before. Do we have v before? I think this is going to have to be like the velocity of relay algorithm. We go down here, double dt. We assumed velocity started at 0, so we're going to have to read the velocity in here. So let's do dd here, and let's do double velocity. But I think what we can do is something a little bit different. Let's just go down here and we can keep everything in a quick object here. So let's do struct. I'm sorry that I'm so out of it today. So if we do struct, I guess ball. 1 second. I will just say double position, velocity, and acceleration. But in principle, these don't have to be doubles. They could be, you know, like an XY position or something like that. So maybe let's just go ahead and do a quick gravity simulation. Yeah, let's do it. I'm workshopping this. So let's do struct position. In fact, do we have something already like that in the vector library? vec.h, and it looks like we do. So let's just do vec. Oh man, I'm so sorry. So let's just do vec position, velocity, and acceleration. Great, fantastic. So now we have 3 vectors in here. We'll work on the constructor and stuff in a bit. For now, I think this is okay. So what we want then is, we have the velocity that we're reading in. And so in here, I guess we're just going to read in the ball and dt. Ball, ampersand, ball. Okay, wait, let me try renaming this guy real quick. So up here, let's call it particle. And down here, let's call it particle. Perfect. Okay, we're not going to return anything because I've changed the way that this works, so this is now going to be a void. All right, one of these days. So down here, we're just going to say simple struct to hold a moving particle. Great, okay. So we're going to do a simple gravity simulation and see how this goes. Because look at me, I know what I'm doing. No, I don't. I'm sorry. Okay. So the acceleration then has some sort of, how do I do it? Like a 3D component to it now, which is great. I guess you're leaving, Roxandro. Thanks for coming in. Appreciate it. Wait a minute. At the Gathros, your pull request for the C convolution implementation contains 1,000 commits. There's one important one. The rest are recommit if you just call it that. 5 are merge commits. Thanks, Gustorn. Particle. Okay, so let's go here. Okay, let's do it. One of these days. One of these days. Hey, Voice of Grog, how are you? So we're going to go here, delete this, and all I want to do now is, I guess, just move it forward 1 time step, right? So we have the X, Y, and Z components, and I think, let me think. So we have the acceleration. I'm going to assume that's normalized in X, Y, and Z. So let's just go through and do it, I guess. So we're going to say particle ball dot, I guess, X, which is going to be its X position. Oh, ball dot position dot X. Oh, this is so good. It's going to be equal to, I guess it's just going to be the previous position. So we're going to do plus equals plus the velocity times dt. So now we're going to do velocity ball dot velocity dot x plus 0.5. That was 0.8 times ball dot acceleration dot x. And it should be okay. Looks like the dot 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 is new here. Say hello. Doesn't show up in his chat on his system. Oh, I apologize for that. I guess it doesn't. I didn't really set it up with Nightbot. I can do that in a bit. So then let's just go ahead and do a quick, I guess, yank $ here and paste that there and add a multiplication symbol there because I'm an idiot. And there we go. Now we're gonna have to do the same for Y and Z. And this should in principle allow for 3D movement. However, I think I only want to visualize 2D. So let's go ahead and do a quick DD there and do our Y here, there, there, and there. And in principle, this should be okay, assuming that the velocity is also changed. So let's go ahead and change that. I don't know the order here, but I'm just going to go ahead and change it up here. So let's go ahead and do D there, Y to Y, P here. And we're going to do velocity and velocity. My brain shuts down as soon as someone walks into my office. But Leos pays attention to chat while remembering to write code too. Sometimes. So let's do, what do we have here? I guess this can be plus equals again, but this time it should be dt. All right, someone in Discord just sent a huge PNG of something, and I'm not sure what it is. It looks like a bunch of merge commits for the recent algorithm, which, by the way, dt here. Oh, when? dt here. There we go. That's what I wanted. Now, what do I want here? I guess it's just going to be plus acceleration times time, so it's going to be ball.acceleration.x times dt, something like that. And then we have the same thing here, except I misspelled ball. I wrote it as bulk, which is a different word entirely. There, so now we should update the velocity and then update the position. And again, I'm going to have to look to make sure that this is the correct way to do this, but we have something going. Let's go from there. Okay, so what I want to do now is just create a giant ball, and then I want to have another ball fall into that ball. Does that make sense? Like, big object, another object here. That's what I want to see. Which means the acceleration will also change as a function of position. So this means we need another function in here, which is just going to be very simply void find acceleration. So let's do find acceleration. In this case, I guess we're just going to read in ball 1, ball 2. So it's going to be particle. Come on. And I guess it's going to be, I'm going to call it planet. And over here, we're also going to have another particle. And we're going to call this one ball. Okay. So now we should have position of the ball, and we should be able to find the new acceleration. And for this particular visualization, I think I'm not going to worry about G or any of that kind of stuff. Like, not going to use real constants. I'm just going to use, like, the basic idea. So pop down here, and we're going to say ball.acceleration is going to be equal to. Now, we have all of these operators here for the vector stuff. Now, it's been a while since I used this, so forgive me if this is not going to work, but I'm going to try it. So we're going to say ball.acceleration is going to be equal to, does it have any relevance to the previous? No, it doesn't. So it should just be planet.position. So we should just be able to take the difference and do here. So vec difference is going to be equal to planet.position minus ball.position. And then we should be able to go down here and say it's going to be 1 over diff times diff. Something like that. But actually what I want is pop down here, double, I guess there should be something in here. What is it? It's the magnitude of the diff is what I want. Operator dot cross double normalize double distance. Yes, that's what I want. And I guess it's going to be, wait a minute, I got to think here. If we have some sort of magnitude, then we also have to have some sort of, how do I put this? Some sort of unit vector pointing in the right direction. So we're also going to have to figure out that unit vector. But I think that should be relatively straightforward because I think that's just a, like finding the magnitude. So we're going to say double diff, and this is going to be equal to the distance between the right and left. So we're just going to say distance here, and we want to do planet and ball. It has been ages since we used this, man. It's like, I know it kind of sounds silly, but this is kind of fun, coming back to the old stuff. So now we have the ball.acceleration, but the problem is that's not the correct acceleration. What we're going to have to do is say magnitude ball, let's just say double acceleration magnitude is going to be equal to this, something like 1 over diff diff, and add something in there, dd there. So now what we have to do is appropriately split this up so that we know the like the unit vectors and stuff like that. So I'm going to go up here, I'm going to create a new vector, and I'm going to say vector, and I guess I'm going to call it the unit vector. And it's going to be equal to the difference between the two. So we should be able to do planet minus ball, right? Dot position, planet dot position. And then we should be able to divide it by the magnitude of these guys. So let's see. We have one minus the other, and then it should be, let me think. So we have, I'm gonna have to draw this one out. Sorry about that. My brain shuts down as soon as someone enters and walks into my office. By the way, guys, I hope you're having a fantastic day. Chat got a little bit quiet on Twitch. It's kind of lively on Discord, though. So if you have any questions, comments, concerns, feel free to go ahead and talk about those as soon as you have an idea of what to talk about. That's perfectly okay. I enjoy distractions, I suppose. Okay, so here's the idea. We have a planet over here, and we have a ball here that's falling into the planet, right? The acceleration is going to be equal to something like gmm over r squared. F equals, gm over r squared, so only one m, which is dependent on the mass of the planet. So if we have this then, the idea then is we have some sort of x, y, and z component to the acceleration. So because it's only going to be a 2D simulation, we only really need to worry about x and y. Now, the question is, how do we do this? So we can find the magnitude of the acceleration, and then all we have to do is after we find the magnitude of the acceleration, we split this up into unit vectors. So this would mean it's like 0.5 in x, 0.5 in y, 0.5 in z, or something like that. And so what we need to do is find the unit vector, which should be, unless I'm being a complete idiot here, I'm just going to draw it something like this. U here, it should be equal to each individual component over the magnitude here. So let me see if we have already a function to create this vector. If not, that's okay. Length normalize left-hand side over length of left-hand side. It's one way to do it. Cross dot operator, operator, operator. No, we do not. Okay, so let's take a look at this here. So the unit vector should be like the x component over the magnitude of the x component, or something like this. Let me Google this real quick to make sure I'm not doing something stupid, because I'm really bad with vector anything. So I'm going to take a look just to make sure I'm not being an idiot. Finding unit vector. To find the unit vector with the same direction as the given vector, we need to, yes, just divide by the magnitude. Wait a minute, let me see. Leos is basically living in the Stone Age with his IRC and Vim. Yeah, that's true. You can simply reduce the acceleration to a single constant, like 9.81 or whatever you want, instead of for different simulations. Yeah, but the difference is here, I actually want to have like this particle orbiting the planet, I suppose you could say. So in that case, I want to have the acceleration changing as a distance, as a function of distance. For now, I guess I could just have it fall directly onto the planet, which is fine. That would work just fine. Let's see, what do we have here? Yep, this looks like it's okay. Okay, so let's pop down here and let's do that. So we have the vector unit vector, and then what I want to do. Hey, I'm currently coding in Vim, and I'm in chat through IRC. Let's see. Voice of Grog, it's not that bad though. Okay, so we have the unit vector here. I think I'm just gonna say, forgive me for this one, distance, because this naming scheme's not great. So then we're gonna do unit vector. I'm gonna see if this actually compiles, because I've got a feeling it's not going to. So I'm gonna say distance.x over the distance of distance. No, the magnitude of distance. Where do we have here? Double dot cross, double distance, normalize. Where is it? Double length? 1 second. It should be. Oh, do we not have the magnitude? We might not. Double length, normalize. Okay. So we have square root of dot left-hand side. Oh, that's actually correct. Length is correct. Good. So let's go down here and we're going to see if this actually works. I don't know if it will or will not, but we'll try. Leos uses VI. Vim isn't that cool. Yeah, I've openly admitted that I should be using Vim, but I am actually using VI. I should probably switch. I just haven't. Thanks, Roxtonro. Appreciate it. Okay, so what I'm going to do then is I'm going to say distance over length of distance. And we should, in principle, be able to do distance.x, y, and z. And see what happens. Yep. And I'm just going to go ahead and pop this down to the next line just to say I did, because I enjoy popping things to the next line. If you know what I mean. I don't know what I mean, so please don't quote me on that one. Okay, so now we're going to pop down here. And we're going to say distance.z, same as we had before. Okay, so in principle, let's just make this to see if it works. There it is. And make. I've got a feeling it's not going to. Great, doesn't. Fantastic. The struct particle has no member velocity. What? Oh, I bet you it's because... Dang it. Okay, let's see what do we have here. Euler ball particle has no member velocity. It does have a member velocity though. That's the thing. It says it right there. Do you not see it? Velocity. All right, let's see what else we have. Vec does not name a type. Did you mean get C? Oh, I think that's because I need to include the appropriate stuff. Pop down here and let's do include. See if I can do this. Visualization. Then I want to do Cairo vec.h. Make that. No match for call. Vec particle ampersand planet ball distance double diff. What else do we have then? 40. No. 20. Double diff equals distance planet ball. I don't think that's a thing. I think I just called it diff. That's fine. And then we don't have diff defined here. So let's just do... Oh, I know what I need. We have this. But what I want is length chotomate sumimasen of distance. Oh, this is great. One of these days, I will know what I'm doing. That day's not today. And actually, it needs to be... Yep, that's what it is. Okay. It did seem to make, so that's something. You know, we're getting there. So let's see, what else do I want to do then? We have the distance, we have the position, we have the ball, we have the unit vector. So then what I actually want to do here is find how much is changing in x, y, and z. So we have the acceleration magnitude, which is 1 over the distance here. We have the unit vector, we have the distance. So what am I actually looking for here? The acceleration is going to be equal to, we have the unit vector. Shouldn't it just be the difference here times the unit vector? Something like that. Also, let me get some more water. If the day you get it is I, then you're doing I++ every day, because you always learn something new. To be fair, I know I've said this before on this channel, but actually, here, let me talk about something. So yesterday, when I was talking to Grant, I mentioned that I do this live stream quite frequently. I said I used to do it every day, but it's been hard to do it every day since, well, basically midway through 2017. But I've been trying to do it more regularly in 2018 because there's a direct connection with the audience that you get. You know, you can directly chat with people, and it's really nice to have that connection, you know? And then he also mentioned at this time that it's probably pretty motivating to have people there to talk to, and just to kind of force yourself into doing some sort of meaningful work every day, if that makes sense. And I just couldn't help but agree with him, because in the end, that's kind of one of the reasons you do it to begin with, you know, so that you have a group of people that you can work with and just kind of do productive things together and learn together. And that's the whole point, you know. I enjoy learning together. All right, so what I'm gonna do next is pop down here, and I'm gonna say we have the acceleration magnitude down there, and I'm just gonna say the acceleration. We're gonna return, and I think I can just do, forgive me if I can't, but I think it should be acceleration magnitude times distance. Something like this. And then over here we're just going to say vec. Make that. Okay, seemed to make just fine. Okay, so now we have the distance, the unit vector, the difference, the acceleration magnitude. Now, do we actually need the acceleration magnitude here? Maybe not. Maybe we're just able to do... Oh, no, this is good. Okay, good. So now we should be able to find the acceleration. We have the ability to change the position of the ball. So in principle, if we start the ball at some location off of the Earth, and we give the Earth some sort of acceleration, we should be able to see how long it takes for the ball to hit the planet. So let's see what we have here. Yeah, I guess let's just do it. So we're going to say, yeah, I know what we're going to have to do. This is going to be a bit hard. It sounds like you and Grant are best buds now. No, we're not best buds. We just had a talk. I like the guy. He's good. He kind of motivated me to see if I can collaborate with other people, because this is something I realized as of this very last video I put out. I think what I want from the channel and what people want from the YouTube channel is slightly different. Will said, Leos, we can come back to remember what it was you told us yesterday. But I put out this last video on the stable marriage problem, and you guys were awesome. Like, you guys immediately took the stable marriage problem and you were like, let's get this working, and it was really cool. Like, it was probably one of my favorite, I guess, experiences after putting a video out, just seeing a whole bunch of people like try to solve the problem, because it actually is kind of complicated, and that was really, really cool. But it wasn't really well received on YouTube, which is weird, because like I was looking at it, it's like the thumbnail is good, you know, the visualization is okay, it's not my best, but it's okay. You know, I was trying to figure out why it was so not well received, but I don't know. I need to figure out exactly how to get people to watch my YouTube channel, because right now they're not, and kind of go from there. But on the other hand, I don't mind so much that they don't watch it too regularly. You know, like, the point of this past video was kind of to have a video history more than anything else, because that's kind of what I'm missing. So Simuleus, well, Better Cake even wrote C# code, but don't tell anyone. Yeah, you guys are great. Like, the moment I saw you guys just chilling on Discord and like trying to figure it out, I was so happy with that. Like, that was one of those times that I really felt like, you know, we have a community, and it was so fun. I really enjoyed it. Okay, so now we have main. Let's just go through and do this. So what we're going to do is we're going to create two balls here. So we're going to say particle, I think capital P, because I'm screwing up naming conventions. We're going to say planet, and we're going to say ball. Okay, so what we want to do is initialize these guys with a couple guys. So we're going to say, I don't know what I'm doing here. So we're going to say planet. Why did I capitalize that P? So let's go ahead and do RP, and we're just going to say planet dot acceleration is going to be equal to 0, 0, 0. And I guess the same for the velocity and everything. And the position, why not? Let's have it all at 0. And position. Great, let's do yank 3 yank. Paste it down here, and let's do something for the ball. So, nope, that wasn't what I meant to do. That's what I meant to do. So let's do a DT there. Nope, that didn't work. Let's just do 6x, and then ball. Great. Okay, so for the acceleration, I guess we're going to find the acceleration, so that should be okay. For the velocity, we're going to set it at 0 velocity. For the position, let's go ahead and set it at 5 in the x direction and see what happens. So what we're going to do here is we're going to say, actually, I think that was okay, what I had there. Something like this. And then we're going to go down here, and we're going to say ball.acceleration is going to equal to find acceleration, and what we need is the planet and the ball. Okay. And then down here we're going to say while Leos, what do we have here? That's our secret. Buttercake. Don't want to lose your open source guy image. Leos just thought yesterday. It's nice how all my kids are playing. Oh, Pro Infinto. Hey, dude, it's been a while, I think. How have you been? So what do we have here? Yeah, as far as, you know, kind of implementing things, I think that's kind of the fun, you know, like working together to learn things. That's okay. I mean, okay. I've said this before. I know this, I've said this probably too many times, but wait, what? Voice of Grog, what? Oh man, I just realized you made the Tesseract video I shared with everyone. Thank you for that. I learned a lot. Oh dude, so here's the thing with the Tesseract video. That video went viral. I don't know why it went viral, but it went viral. And the thing was, when people were looking at the video, a lot of them, like the comments, they're all people who don't understand it. And I felt bad because I was like, man, I guess maybe I overshot this one. You know, maybe it was too complicated, you know? But when I was watching it, I was like, you know, the point of the video was really to show that if we're going to go from 4D to 3D, we have to project it onto 3D. Oops, sorry about that. And I'm not going to take the video down just because people don't get it. But I'm glad that you were able to understand it, because recently, like, all my comments are from people who were just like, what? I don't get this, you know, this isn't really understanding 4D, all this kind of stuff. And I'm like, I'm sorry, this is how I understand it. It's best if you just look at it mathematically and you go that way. What am I gonna say? I'm gonna say from now on something. What am I doing? I don't know what I'm doing anymore. So while I guess I want to do while distance. Man, what am I doing? There has to be some threshold here. So I guess I'm gonna say double threshold. I totally got sidetracked, and we're gonna set this equal to, let's do 0.1. I went down a rabbit hole that day, and your video clicked for me. Interesting how it was received so differently. Yeah, it depends, you know. The thing is, obviously, people who are going to be leaving comments on the YouTube videos are probably the ones who didn't get it more than the people who did. But I'm very glad that you did get it, because that's really cool. There's a couple videos like that I have out that they don't work for everyone, but when they work for people, it really helps. The other one was the determinant video, which I took down for a while because I really liked that video. It was one of those that gave me a good physical intuition to what the determinant was. But a lot of people, when they watched it, they were like, you didn't show how to calculate it. And I was like, no, I didn't show how to calculate it. Because my assumption was you learned how to calculate it in high school. This was another way to understand what the determinant is. And so there are a couple videos like that are kind of over people's head. But not intentionally, it's just what happened. But I'm very glad that you appreciated that content. It's pretty good. Okay, so what I need to do is find a way to basically find the distance between the two, which means, oh, I know we have the library up. Double length, what am I looking for? We have the cross section, the dot product, the operator. What am I looking for? I'm looking for the magnitude of the distance between the two. So I guess I want the length of the distance. So let's do that. Oh, no, it's just distance. One of these days, I will know what I'm doing, but that is not today. And we want the distance between the planet and ball. And we want, while this is greater than threshold, we go forward. Okay, so assuming everything works correctly, in our 2D space, we'll have our planet, we'll have our ball, the ball will fall towards the planet, it'll get sufficiently close enough, and everything will stop. That's probably not going to happen. But if it does happen, it'll be really cool. We need to kind of figure out what's happening. So first, what we need to do every time step, we're going to say ball.acceleration is going to be equal to find acceleration between planet Oh, come on, I can do this. Planet and ball. Okay, and then what we need to do on top of that, DD here, DD there. Then what we need to do on top of this is, what do we need to do? We need to do the Euler ball. And I think it should be okay if we just do Euler ball, and we do ball and double DT. Now what should DT be? I guess I'm going to go up here and define that. Yay, paste, and we're going to call it DT here. Yeah, let's leave it 0.1 for now, DT. So in principle, assuming that this is working the way we want it to, in principle we have a DT at 0.1, we have a threshold at 0.1, the ball is going to fall into the planet, they're just going to explode. Okay, I don't know how the explosion is going to happen, but one day it'll happen. And then I guess we'll just output the position every time step. So let's just do print vector for the ball position. And let's see what happens. So we're going to do print F, I suppose. Oh no, print, and I just want to do vector V, so this is going to be ball dot position. I forgot a semicolon here. Add a semicolon in there if I can find the semicolon. There we go. And pop over here, and let's just make that. Great. Couldn't convert planet from particle. That's because this should be planet dot position, and this should be ball dot position. Write this, go over here, make that. Planet greater than threshold. Expected primary expression before. What did I do wrong here? 49. Ball dot position, planet dot position. What am I doing? While the distance between the planet dot position and the ball dot position. Oh. That's, I think, what I was doing. Did that make? I think it made. So let's just do / Euler. All right, great. It's not working. Why isn't it working? What is happening? I probably should have output this to a file or something. Yeah, okay. It's going faster now. I'm not really sure what's happening. Let's just control C here. And let's output the first couple time steps. So I'm going to do 4 int I equals 0, I less than, I don't know. I could use cout, but if I did cout, I'd have to do print. I have to do cout position dot 1, 2, 3. We had a special print function specifically for vectors, so I'm using that one now. So we're going to do I less than 10, let's say, and then plus I, something like this. So we just do the first 10 time sets. We make this and see what happens. I also want to print out the acceleration. So I guess I'm going to say print ball.acceleration, and let's just see what happens. Maybe we should also print out the velocity. Yeah, screw it. Let's do the velocity too. So we're going to do acceleration, velocity position. And this should be okay. So I'm also going to do a quick down here, std cout, just a new line, I guess. Something simple. Yeah, sure, something like that. Right here, go over here, make that. Nope. No, that's not what I wanted. Make that. Euler make. Okay, so we have the position. Sorry, the acceleration is negative 0.2. So that means it's falling this way in the x direction. Its position is 5, negative 0.2. That seems correct. The next one, the acceleration is still the same, which is still fine. Now, is 0.2 correct? Yeah, that's correct. It's 1 over 5. It moves 4.9, 4.9. Oh ho! It seems to be working just fine. So let's do 100. Okay, this seems to be working okay. Its position. So I guess I also want to output the distance between these guys, because it seems the distance isn't working quite right. So let's do std cout, and I'm going to do distance between planet position and ball dot position. Maybe the dt was just too, I'm not sure. Make that. See what happens. So I'm going to do Euler. I think that position is incorrect. Oh, no, wait. I was incorrect. Okay, so here we have the distance. 3.99, 3.84. How does it get bigger all of a sudden? Okay, let's go through this. So we have the acceleration. The acceleration is constantly increasing, and then it gets super far away. Let's try dropping the dt. Make that. I think the position is being updated. Yeah, because the position is definitely different there. But there's something weird happening here. Okay, so we have the position at 0.5, 5.08, 5.34, 5.48. I think I know the problem. The acceleration here should be negative. Now let's see what happens. Well, okay, it's different. What do we have here? 8, 7, 6, 5. Okay, it seems to be getting further away still. Oh, did I not make this? I probably didn't make it. No, what? You were not up to date. Make that. That's not how you spell make. Let's try it one more time. Now let's try Euler. Dang. Why are you still going away? The acceleration should be negative. This one is positive. Wait a minute. Let's remove this guy. Go over here, make that. Oh, ha, ha, ha. Oh, that's a bug for you. Let's see what's happening. Dot / Euler. Okay, well this is different at least. So let's see acceleration. The acceleration starts at -2. It increases from there, which is what we'd expect to see. It goes faster and faster. The position drops until it looks like about here. But the y position is it's not going like this. It's going like this. Why? It should just be going straight in. It should just be bam, you know? That's not what's happening. So why would it be not doing that? Okay. The y position, it's like falling at the same time. Why would it be falling? There isn't an acceleration in that direction. Or there shouldn't be. There's no acceleration in that direction. Ball.position.y plus equals ball.velocity.y. Does it have a velocity in the y direction? Yes, it does because of this. Y. Make that. Euler. Okay, let's see what happens. So good news, the y and the z position stay 0 constantly. Also good news, we have the ball moving forward. And perfect. Yeah, great. I'm okay with that. Yeah, I'm okay with that. Okay, so now what we're going to do is change this here back to what it was before. Make that. And let's see if it stops. It stops. Booyah. Okay, so that means we have the ball, it's moving into the planet, which means we have something kind of sort of working. And more than that, we know that if we give it a slight kick in some direction, we can actually see it spiral around because of another problem we had in the visualization before. So I'm going to leave both these methods in here. Now we have to get the visualization up. Let's see what we can do here with the visualization. I'm just wondering, if you have a vet class, why do you have to access the individual dimensions? Should you not just be able to perform basic operations upon the vector as a whole? Yes, I can. I was just being an idiot. So if I do down here, I can probably do ball.velocity. It's going to be equal to ball.acceleration times dt. I'm sure I can do this. At the time, I didn't realize what the vet class could do because I had forgotten about it. Ball.position. Yep. So I can do the same thing down here. And we can do ball.position. It's going to be equal to ball.velocity, ball.acceleration. And then I can probably just remove these guys here. And it should give us the same thing. Yep, great. Okay. Perfect. Okay. I'm sorry. Let me think. Now, the question is, how should we tell people to do this on the algorithm archive? I was thinking that on the algorithm archive, we do something like maybe orbiting or something. That's fine. We'll do it when we get to it. So now we have to do the visualization. And the question is, how do we do that? We have a position of the ball at every time step. We have a position of the planet. We can just draw the two. And I think that might be the way that we do it for now. So the question is, what am I doing and how do I get that done? Am I able to move balls around with the visualization method I have for the Cairo visualization? Let's see. So I'm going to go over here. What am I doing? There we go. And I guess what I want to do, quit. Let's go into VI visualization test.cpp. And what do we have here? I guess what I'm going to do is go ahead and initialize all the components and go from there. So we have vector resolution, the int FPS, which is 30. I can understand you were coding hard. Thanks, Roxtandra, appreciate it. So we have vector resolution, int FPS, color, background color, and I should, in principle, be able to put all of this into something. Grow circle here, the layers of 1, init layers, that's what I want. So let's get this done. So I'm going to go ahead and put in here, I guess I'm going to call it function to initialize the scene, and it's just going to be what I have over there basically. So void actually should be, how about std vector of layers, actually frame, and then we're going to say equals in I guess we're going to be init scene or something like that. And in here, we're going to need a couple of different guys, I guess. Int FPS is 30. Now let's just do init scene like this. All right, and let's just put everything in here this way. So we're going to do, I'm just going to grab this guy because screw it. I don't care about my life right now. I mean, I don't care about, you know what I mean. You don't know what I mean at all. Okay, so this should be okay. And I want to just return layers. So we're going to say return init layers here. Okay, so now we have the layers initialized. And the way this works, we're basically working off of Cairo. So the idea is we have a whole bunch of different frames, which is going to be a frame by frame in time, but we also have 3 different layers to draw off of, and we can add more and more layers. I'm sorry, Buttercake, that probably didn't make any sense and probably sounded really depressing. That was not the intention there. Okay, so we have this guy, we have all those guys initialized. I guess in principle we can just go. So let's do I guess we're going to say layers is going to be equal to init scene here. So now we have the vectors here, and I think what I need to do is std vector frame. Okay, so the first thing I need to do is draw the circle and draw the rectangle. Now let me think, how do I do this? I think we have the line color 1, line color 2. So let's go ahead and create those guys. So we're going to say color, and I guess it's going to be color 1 and color 2. Let's see, it looks like one is white, the other is purple or something like that. So I guess we're going to call it white. It's just going to be equal to 1, 1, 1, 1. There we go, something perfect like that. Shoot, okay, it's not perfect because it's white. That wasn't racist. I'm sorry, I'm not racist. ABDCW, you still working on the stable marriage problem? No, the stable marriage problem is done actually. Oh, I didn't realize it still said that on Twitch. It probably does still say that on Twitch. I'm sorry, I'm working on something else today. Synesthesia, wait, synesthesia. Yeah, hey, how are you? By the way, synesthesia is super cool. I think you've been on here before, and I've talked to you about it before, but one of the first things I ever researched as an undergraduate was synesthesia. It's super cool to me, like amazing. I really like it. And let's see, what do we have here? We have color white. Yeah, let's just keep going. What I want to do is just grow the circle and stuff. So how did I do this before? We did grow circle. We grew it on a particular layer. We said 1. Oh, it takes 1 second to draw. We give it some position. It has some radius, some dimension, some line color. What is dimension? Okay, I don't actually know what all these do. So let's just try something. We have grow circle. Let's just do it. So we're gonna do grow circle. One of these days. So we're gonna do grow circle, and we have two positions. Grow circle. So we're gonna do layers of 1, which is just gonna be the middle layer. Then we do 1. We want the 2 positions, so we're gonna do planet dot position and planet dot what do we do here? Planet dot position and planet dot. Wait, 1 second. Origin is gonna be the planet dot position. I guess it's gonna take 1 second to draw. It's gonna start on. I don't know what these do. Well, let's see what happens. I'm not sure what any of this does. Okay, so the vector origin is at 200, 150. So what I actually probably need to do is create a function to map where everything we are drawing is on the screen. So now I'm just going to pop down here, G, and I'm just going to draw layers. Okay, let's see what happens if we just write this, go over here, right quit, make. I'm not sure what's going to happen. I have no idea. So let's just run this. Where are you, dog? Oh, oops. Wrong directory. Make. Of course it doesn't work. Frame was not declared in the scope. Init vector, not a member of STD. Ah, great. That solved some problems. Color was not declared in the scope. What was declared in the scope? I'm not sure. Okay, what do we have here? Chiroviz.h. That seems fine to me. I'm reading in. I'm not reading in. One of these days. You showed me your book last time I came here. That was like a year ago, though. Jeez, it's been forever. Let me think. Oh, speaking of which, I was talking to when I was talking to Grant yesterday. I pulled out this book, Thermal Physics, because in this book, like somewhere in the back, they mentioned something about an algorithm that I wanted to cover, and I thought he might be also interested in. So I pulled out this book, and I was like, "Yeah, it's in this book." And he's like, "Oh, I have that very same book," and he pulled out the same book. It was really kind of funny. I don't know. I thought it was fun. Okay, so what are we going to do next? I am going to do something with my life. Eventually. Not today. Great. Okay, let's see what the problem is. Expected initializer before init scene. What? SE vector. Oh. Make that. One of these days. Wait. Yeah, because I watched your video yesterday. I was wondering why I saw balled up position. I'm not, no, Gathris, I don't really know Grant that well. We just had a chat. He's a cool guy. Really like him. Hey, Gelbart, how are you? Thanks for coming in. Yeah, I'm sorry. We're moving on to the next thing, which is Euler Methods. I just forgot to update the title. I should have probably done that. Hey, Thornforge. Okay, so let's see if I can get this making. Hopefully I can. I want to do a super basic visualization before the end of today's episode. That's it. Just something super basic. Okay, what are we going to do here? No matching function for grow circle. Okay. Grow circle. G here. What do we have for grow circle? Layers 1. Planet. Uh-huh. Uh-huh. Let's try that. What am I doing? Make. Ah, dagnabbit. Make. Dagnabbit. Okay, grow circle. I think it's right. What am I doing wrong? Layers. I am doing it wrong. What am I doing? 1 here, and then we have planet position there. So we do this and that. That should be okay. Then I don't know what I'm doing, but I'm doing it so wrong. Make. All right, it made. Now let's run it. Euler. ls temp. I think they're all here. So let's do mirage temp image 00000.png. We should see a circle appear. Yeah, we saw a circle appear. Booyah! All right, getting there. Which Euler explicit? Yeah, so we're doing, the forward Euler method, basically. And then from there, we want to move on to the other methods. So here's the thing. Right now, Euler methods in, what is it? Here. So for the computational physics, Euler methods are just abysmal. This chapter needs to be redone. And so after we do this, then I figured we go backwards to Euler method because we already have in, we already have Gaussian elimination and the Thomas algorithm up and ready to go. So these guys are basically set. All we need to do is get the forward Euler understood. And then after we do the forward Euler method, we can then go from there. So I'm pretty sure, this will be relatively straightforward. I haven't decided where we want to go from here though. I'm thinking we do forward Euler, then we take a step back, do number theoretic transforms, maybe go into the Schoenhagen-Strassen algorithm because it's amazing, and then after that we go to maybe backward Euler again. I don't know, I haven't really decided the best way to go. At some point I really want to go back to the Barnes-Hut algorithm because that algorithm is amazing, and every time I think about it I'm just like, man, people are so cool, and I haven't had a chance to just, do it. Okay, so what are we going to do? We have 30 frames per second. We have to grow a circle there. We also have to grow another circle. So what I need to do is create a function in here to map coordinates. So I'm going to go down here. I'm going to say function to map coordinates. Great. Okay. Pop down here. And so I guess it's going to be, that is not how you write a function. We're going to say vec and position. Map coordinates. Great. Okay, so what we need then, and in here we're going to have to read in the layer size. So what do? It's going to be std vector frame. And I guess it's just going to be frame, and we're going to call it, what did I call it? Layers? Something like that. Yeah, that should be okay. So what we need is to grab the resolution of our visualization. Honestly, that's all we need. Let's just get the resolution. So let's just do vec resolution in here. Okay. So now all we need to do is if we have 0, 0, 0, this needs to appear at the center of the screen, which means we have to take the vector that we have, which is in this case 400 by 300, and we have to shift it by 400 and 300. So we have the vec resolution, and we also have vec position. Something like this. Okay, so now we need to return the following. Hopefully I can get this right. So it's going to be, it's a double position, right? So let's see, we're going to have to do, we have to have some x max or something that we're dealing with here. So I guess what I'm going to do is double position and, I'm sorry, vec max or something. I haven't quite decided the best way to do this, but we'll get this working. So we have some sort of maximum value there. And what I want to do is figure out where our position is in this double space, and then I want to move that to the integer space, which is the space with all the pixels on it. So what we're going to have to do then is we're going to have to say, vec position. If the position is 0, 0, 0, we know the location. It's going to be 200, 150. Not an issue. So now the question is, what do we do from there? Is that update in Euler ball correct? The dimensions are not length. Euler ball. You're totally right. I apologize for that. I forgot a dt here. Now it should be correct. Position is equal to x plus v naught t. Yeah, this should be correct. I apologize. Thanks for the update. Okay, so let's go ahead and return this. So how are we going to do this? I guess what I want to do is find the distance between... Wait. We have to find some sort of like magnitude or something that we're doing here. So let's just do the following. So we're going to say distance. We have how big it is. gonna have to draw this out. I'm sorry. New page before. So we have a range that goes here, here, okay? So this is our x max. We have some particle that's here. So we'll say this is 0, and here's our particle. Our particle is at 0.01, and this max is 0.5, okay? So we have to figure out where this guy is on this range. So what we need then is, if we have x max, so x max is going to be equal to 1 in this case. So then its position will be its current position. Let's say x max is equal to 2 in this case, so this is 1. So it's going to be 0.01 divided by 2 plus 2 times 0.5. Okay, so that's going to be its position in double space, and then its position in integer space, that will be, 1 second. So this will give you the offset. So then this will give you like 1, basically. Yeah, it'll basically give you 1, so you're basically at 1. And then in double space it's going to be, or in integer space it's going to be, I guess it's going to be frame size, so it's going to be 400 or whatever is in the x direction times, and then I guess it's just going to be this x position divided by x max. There we go, that's what I need. Okay, so what we need to do is find the distance here. So we have x max. I'm going to assume that's like the total extents here. And then what we need is the position divided by x max. And so what we want is the difference between the two. So we're going to say difference is going to be equal to the position minus, wait. We're going to say position divided by max. 1 second. And then we're going to add in 0.5 times max. Something like this. I'm going to put these in parentheses just to be safe. Okay, so that should be its double position. So we're going to say, let's do vec double position. And now we have to return double position dot x. Actually, it should just be double position times, and I guess it's going to be vec resolution. 1 second, resolution, and then we want one more thing, which is going to be plus x position over x max. So it should be plus, is this correct? 400, no, I'm doing it wrong. It should be resolution. I'm so sorry, this is so confusing. I know it's confusing. It should be resolution times x position over x max. So resolution times double position divided by max. Something like that. So now we're going to pop down here, G, and we want to do grow circle. But what I want to do is create the position. So I'm going to say vec position is going to be equal to, what did I call it? I called it map coordinates. Map coordinates. And let's do map coordinates of, let's see, we want the planet opposition. Why am I so bad at this? It should be the position, the maximum position, and then the resolution. So we're going to want planet opposition. Then we want max. And then we want the layers of 0 dot resolution, I believe. And then in here we're just going to say max is going to be equal to, let's say it's 5 large, so it's going to be 5, 5, 5. Maybe we don't need a z. Make that. Oh, that wasn't what I wanted to do. Make that. Okay, what do we have? Resolution times double position, position divided by max. No match operator, vec, and vec. Dang it. So let's go into vi vec.h, and I don't have, there is no division, I guess. No, there is a division. What do you mean no position for operator division? Vec and vec. You should totally work. You're right there. Ah, come on, man. What is this? Okay, pop up here and let's see what's happening here. Init scene, map coordinates. Vec left-hand side, vec right-hand side. What are you telling me, dog? Position divided by max, operator. No match for operator star. Am I missing something else here? Is there something? Layer 0. I see the problem. Okay, so let's pop down here and let's see what we got. Well, there's one problem at the very least. So let me also do vec resolution, because I realized I also did this wrong. Vec resolution is going to be equal to layers of 0 dot res x layers of 0 dot res y and then 0. In Euler ball function, shouldn't the position be updated via position plus equals? You're actually probably correct. Yeah, I think you're correct. Thanks, Galvabart. So we're going to do dt here. It's probably fine. Wait a minute. It's probably fine either way. But yeah, we'll leave it here for now. I need to take a look at the Euler method. Yeah, you're right. It's probably that way. Yeah, that's probably correct. Sorry, I'm doing it really roughly. I just need to get this working. So let me do here, and let's pop down here. Change this just to res. Make that. Warning conversion. Yeah, that's okay. The warning's fine. Operator star, but I know you exist. Don't give me that. I know you exist. I've used you before. I don't understand. Why are you telling me you don't exist? It says this operator star doesn't exist, but I used it just a second ago. Did I not? Am I missing something here? Let me just try changing this to a minus to see if it compiles. Dang it. Why does that compile? That one doesn't compile. Okay, so it doesn't like the dividing. Why not? Oh, I think I know why. Let's just go into operator minus, operator plus, operator divided, vec, inline vec. I don't know. Am I reading the wrong vec.h? Visualization Cairo, vec.h. Make that. Operator or vec and vec. No for operator star. No known conversion from argument 2 for vec to double. No match for operator star slash operator type vec and vec. 1 second. Candidates are vec operator vec double. Inline vec operator slash vec left hand side right hand side. But it looks like it's fine. No conversion for argument 2 vec to double. Okay, let's just do this another way for now, and we'll get back to this in just a second. So what I'm going to say is double position is going to be equal to position.x, max.x, 1 second, dot x, 0.5 times max.x here, and I'm just going to do x, y, and z for now. And then we'll come back to figure out why this isn't quite doing what I want it to do in just a second. And now we have to do the same for y and z. I'm just going to yank and paste. And we're going to do here, there, and I want to do y's here. 1 second. Then we want to do z here. Oh, except that should be 0. So let me just t there and do that again. And let me just do 0. Great, okay. And then we have to do the same thing down here. So let's do return. And I guess it's just going to be, oh, let's see, how do I do this? I guess .x, position.x, max.x. And then we just put in a guy there. And we do the same thing for resolution.y and then 0 for z. Something like this changes to y. And we'll come back to this tomorrow to figure out why the thing's not working right. Let's make that. Okay, what's the problem now? 25. It says 0. It doesn't like 0. Why doesn't it like 0? That's a good question. Expected that. Yep, you should have expected that. It's good that you're keeping you on your toes, compiler. That's what I'm doing. Let's make that. Okay, that seemed to make, I think. Did it? No, it didn't. Or did it? No, it did. Okay, so let's do the last /Euler. See what happens. And then we have to take a look at the last mirage. Nope, you're still back up there, but you shouldn't be up there. You should be somewhere else now. Let me think. Grow circle, layers 1, planet opposition. That's because you should be just in position. Make that. Make that. And now let's try one more time. Euler. See what happens when we do mirage temp. There we go. Circle right in the center there. Booyah. Okay, so this is great because that means we have something kind of sort of working, which is fantastic. Okay, so now we have to draw the position of the other guy. So we're going to say we want another circle, which we're going to draw here. We're going to say I'm just going to do yank here, paste there. I'm sorry, this is really messy. And we're going to say this is going to be size, let's say 50. And this is going to be size 10. And it's going to be at the position of the ball. So we're going to say ball. Make that. Vec position was already declared. So let's pop down here. And make that. And we're going to do Euler. 1 second. Euler. What am I doing? The last mirage. And we have a circle there. And we should see another circle there. Yeah. Okay. Great. Perfect. Okay. So we have the planet. We have the ball. Now we just have to make them move together. Don't know how to do that. Okay. I thought you were doing some complicated math stuff. Now we have a circle. Yes, we do have a circle. Okay, so for now, guys, I think I'm going to go ahead and close it here. Maybe I should commit this. Let's see, get status. Oh, this is going to be a bad idea. I knew it was going to be a bad idea. I should not have typed get status because this directory is awful. Okay, so what I'm going to do then is, right quick, get status dot maybe. Okay, get dot. Let's do makefile and Euler dot cpp. Do // visualization ls cd Cairo. Let's do the last get status. See what's changed here, and it looks like we modified. Did we modify everything? Let's do get diff. I modified a few things. It looks like. Yeah, sure. Let's do it. Get add dot. Oh wait. Get status dot get add makefile Cairo viz.h and viz test.cpp. Get commit -m. 1 second. Adding stuff. And let's do get push origin master. Am I on master? Let's see. All right, I was on master. Good for me. Okay, so two things to note here. One, the old visualizer is working fine. We didn't quite get to the point where we see the ball orbiting the planet. We'll get there tomorrow, and that's kind of what I want to do tomorrow. And then after that, we'll try to do another ODE solver for the next bit. You know, so since Euler methods can do general ODEs, and it's not like relay integration, which is basically specifically for, you know, velocity and stuff like this, I figured we do something more complicated. We also have to show like error terms and things like that. There's a lot of things to do here. So I think for now, I'm going to go ahead and close stream. Thank you guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos when we do stuff. That's about it. So thanks, guys, and I will see you around. Bye, guys.